test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers is it, triggers is it, triggers is it, triggers is it. Seeing Mr. Ng's face during period 3. Triggers is it, triggers is it.
Hey math lovers, let's go over 1.71 graph a quadratic inequality. Let's go ahead and complete this. Do this with me. Well, what's standard form for quadratics? Y equals ax squared plus bx plus c. When a is less than 0, it's a sad face. I just saw this. You guys get it? But when a is greater than 0, or positive people, so to summarize that basically means when a is negative, it goes down, and when a is positive, it opens up. The c value is the y-intercept. The c value is the y-intercept. So that's a quick review of standard form. Notice there are no parentheses there. All right, let's go to steps to graphing quadratic inequalities. Step number 1, we need to graph it. We need to graph it. Remember, when it is less than or greater than, it's going to be dashed. And when it's less than or equals to with a line underneath, or greater than or equal to, it's going to be a solid line. The second thing we need to do is we need to test it. Test. And the best one to use is the order pair or the origin 0, 0. Now make sure you're testing a point not on the parabola. If you can't pick 0, 0 for some reason, you just pick another order pair. And then thirdly, we're going to shade accordingly. Shade accordingly. Okay. How do you do this? We're going to do this by hand. You shouldn't just put into the technology and get a graph. We'll eventually just do that. But if you can't graph it by hand, you might want to go back to lesson 1.1 and 1.2 about graphing in standard form. But you can use technology, and I'm going to show you guys a graphing calculator, which is like a TI-83. It's my iPad app called Graph and Calc 83. That's how it's spelled in the iOS App Store. Sure, Graph and Calc 83 right there in the black with the spiral and the flower. And then you can also use the Desmos app, which I'll try to show you guys on a couple of those. Okay. Let's go ahead and try number 1. Y equals x squared plus 6x plus 4. Okay, this one already looks like I can tell you can't factor this to find our x-intercepts. So if I'm thinking to myself out loud, can I factor this? No. Could I use the quadratic formula? Yes, you could. Alright, for this situation, for graph, I'm just going to use my tech. So let's go ahead and punch this in. So I'm going to press clear on the home screen, and then top left I'm going to press y equals. I'm going to clear this out, and I'm going to type in x squared. You could use two ways. Up there by alpha is the X button in white. You can press that twice. That's my fastest way of doing it. Another way you can get x squared is putting x, and then over on the far left near 7 and above log is the square button. Now I'm going to use the plus or minuses, which is the blue keys in the bottom right. So plus 6x plus 4. Now, if you're using a traditional graphing calculator here, you would press zoom 6. Zoom 6 would give you like a standard one. But the nice thing about a tablet is if I just press graph here near the second key, I already have a graph. Okay, so a couple of things that I just want to point out here. If you click and move it, you'll notice that it's near. And the nice thing about this one is it says 0. That is where it crosses the x-axis, so negative 76 and negative 5.23. Alright, so I'm just going to kind of generally put those there. 0.76 and negative 5 is between negative 5 and 6. So that's 4, 5, 6, closer there. Okay, so these are my x-intercepts. This is my y-intercept, so 4. That doesn't look right. Let's check. Negative 0.76. That's how I knew. Why did I knew that was weird? Because you can't make a graph go like this because I missed that one point. Does that make sense? Okay, so let's just move this one. Negative. Okay, I can just erase it and move it. Okay, so here's my graph. Okay, so what have we done so far? We've graphed it. I know that it's going to be a solid line because it has an equal sign below. It is a solid here because it has an equal sign right here. Solid. Okay, now I need to do a test point. And my test point is going to be here. A test point means that if it's true, then we shade it. So let's go ahead and put in that. 0 less than or equal to 0 squared plus 6 times 0 plus 4. So 0 is less than or equal to 0 plus 4 is 0 less than or equal to 4. Is this true or false? This 0 is smaller than or equal to 4, so this is true, which means shade. And it's helpful if you just so where the 0 is in green, that's where I'm going to shade. I'm going to shade everything here on the outside of the parabola. Notice how I am not shading stuff inside the parabola. Okay, so there's my rough sketch, and I could have gone the vertex. That probably would have been a good one. Let's get that. There, my minimum is -3, -5, -3, -5. Left 3, down 5. So that would have been a better graph. Let's see if we can make it a little bit more accurate. Something like that. Okay? All right, question number 2. let's do the same thing here. Can you factor it to find our x-intercepts? No. No two numbers multiplied to be 6 but added to be 4. Can we do the quadratic formula? Probably. I can just use my graph. Okay, let's go ahead and locate the y-intercept. There's my y-intercept there, -6. And our graph is negative. My a value is negative, so my graph's going to be going down. Okay, let's go ahead and punch that into our graphing calculator. Okay, in this problem we had negative x squared. So you just clear that out. Negative sign is to the left of the enter, Notice how that's a subtraction sign. You'll notice the different sizes. So some calculators can actually differentiate the two. This one you have to use the negative sign again, which is to the left of enter. So I'm going to press delete. Negative x squared plus 4x. Okay, minus is the blue button to above enter, -6, and then graph. Okay, what do we notice? The discriminant was less than 0, so there are no real solutions of not crossing the x-axis. I have a maximum at 2, -2, 2, -2. Let's go ahead and put that there. You know, to get that value, I could have just done x equals -b over 2a, and then put that into the function to get the order pair 2, -2. Let's change colors. Can I not read? It was 2, -2. That's what it said. I can't read 2, -2. Sometimes, not all the time. Okay, right 2, down 2. And then our parabola is going to look something like this. Okay, so then let's go ahead and just test this. So I'm going to put in 0, 0. Whoops, that's inequality. 0 is less than -0 squared plus 4 times 0 minus 6. And 0 squared is 0, opposite of 0 is 0, 4 times 0 is 0, and is 0 smaller than -6? If you need representation on the x-axis, these are smaller numbers over here, negative numbers, and here are positive numbers. So is 0 smaller? This would be false. Okay, so this is the red dot that we tested. It is false. That means we don't shade. Shading is the solutions. Shading is the solutions. So let's go ahead and graph that. Color like blue. Which means that you shade where? You're going to shade, whoops, kind of hard to get, in the inside of our graph. Okay? So the two choices are outside or inside, and with my test point, it tells me where to shade. Okay, let's go ahead and do number 3. Notice that this one has no b value. So my c is my y-intercept here. My a value is positive, so it's going to open up. When there is no b value, that essentially means it's going to be, it's going to go through the origin, but it'll just shift it down 4 units with that -4. Now, what happens if you can factor it, like this problem? If you factor it, you'll get this. And then you set it equal to 0. you've got x equals 2 and positive 2. Okay, let's change the color of that. Okay, so 2 and negative 2 means your graph's going to look like this. Okay, if you wanted to graph that, clear xx minus 4, and then just press graph. And there it is. 2, negative 2, and a minimum for your vertex. In this case, the y-intercept and the minimum are actually the same order pair. The y-intercept is 0, negative 4, and the minimum is also 0, negative 4. Okay, now we're going to test this. So we're going to test it with the order pair 0, 0, as long as the graph is not going through 0, 0. Is 0 smaller than negative 4? This is false, which means we don't shade. So the order pair, here it is, 0, 0. I'm not going to shade there. Don't shade. So that means we shade everywhere else. So in this case, it is on the outside of the parabola. Okay. So question number 4. Now, if you basically think about what we did in the last problem, this is my y-intercept. You're basically going to have the same thing here. This is going to, A is 1, so it's positive and it opens up. This textbook did not teach you guys reference points, but if this was the origin, the green dot, it would go right 1, up 1, right 2, up 2. Left 1, up 1, left 2, up 2. Should put it up there. And you can verify that by graphing it. Just go here, change it to plus sign, and then press graph. See? And then we're just going to test this. So again, why do I pick 0, 0, the origin? It's the easiest one to test. 0 is less than 0 plus 4, so 0 is less than or equal to 4. 0 is smaller than 4, so now we're testing this sort of pair, so that is true, which means we shade where that dot is. So look at the dot, either you're going to shade it or don't shade it. If you don't shade it, you shade it in the other region. So we're shading there on the outside. All right, let's go over question number 5. Y equals less than 2x squared minus 4x minus 2. Let's get some characteristics that we can tell from here. Here is my c value, so this is my y-intercept, negative 2. My a value is positive, so it's going to smile, it's going to open up. And you can try to quickly factor this to see what happens. Can you factor that? Two numbers that multiply be negative 1, but add to be negative 2. Nothing. Let's go ahead and graph it. Y equals 2x squared minus 4x minus 2. All right, so our zeros are rational. Actually, it looks like they are irrational. 2.41 and negative 0.41. And I should get a vertex or a minimum. 1, -4. Write 1 down, -4. This is a minimum. And okay, let's go ahead and do our test point now. I'll use the original equation. We're going to test 0, 0 here in green, that green dot. So 0 less than 2 times 0 squared minus 4 times 0 minus 2. 0, 0 squared is 0, 2 times 0 is 0, -4 times 0 is 0. Do you see why we're using the origin? 0 is less than -2. This would be false, which means don't shade 0, 0. Don't shade 0, 0 means I'm going to shade everything else. Don't shade where the test point was. And number 6. This one looks a little bit funny to you, so you can just actually switch it all around. Notice how it's pointing to the y variable. Let's just see if we can factor it. -1. And does it work? Okay, here you can do a couple of things. You can, this is essentially in vertex form. So that would mean that my vertex is at 6, 0. Oops, what am I doing? Okay, so this is negative, so down. And then from the original equation, -36 is the y-intercept. Way down there. It's probably look something like this. And you can double check that. -x² plus 12x minus 36. And just like we did. Okay, let's test this now. So I'm going to put in the origin. I'm using the original. So all that will become 0, 0, and is 0 smaller than -36? This is false. False means don't shade. So don't shade the sign that has 0, 0. So in this case, that would be in the inside. Is in question number 2, these should be dashed. And what that means is anything on the order pair, anything on the graph itself, the line there is not a solution. Not a solution. And then for number 5, same thing, should be dashed. And number 6 should also be dashed. Okay, see you guys later. Bye.
We doing math today, ain't got time for no games.
We doing math today. All work and no play. We doing math today. Listen up and behave. We doing math today. We doing math today.